Hello everyone, a very warm welcome to this video. In this video, we are going to talk about our first ecosystem project, that is Sqoop. Now, as soon as you learn Hadoop, the first thing typically for a POC that your manager would ask is, can we take some data from relational database and dump it into HDFS cluster? Now, before you start writing your code, you should know that you have a best friend called Sqoop. Sqoop is a tool that will basically let you ingest data from relational databases to HDFS. So what Sqoop really does is, it's a command line tool that takes a command from you. Once it takes the command, it runs a Java code that will basically talk to the relational database and get the data from relational database. So let's understand how does Sqoop really work. So you have your HDFS cluster. Hadoop. On your laptop, what you have is a Hadoop client, and then you have a Sqoop client. You have your relational database. Now, as a user, you would first submit your command to the Sqoop client. Once you submit a command, Sqoop takes your command and first goes to relational DB and verifies if the table is existing or not. If the table exists, Sqoop gets the metadata of a table, and based on that, Sqoop converts the whole thing to a Java program and submits the program to the cluster. Here, the cluster, that's resource manager, just like a normal MapReduce program, would accept the job, call the app master, and app master will fire 4 MapReduce programs by default, where each map program will get 25% of data from relational database, and you get your data. And Sqoop, to connect to relational databases, uses JDBC. And because it uses JDBC, it can virtually talk to any database in this world. Just to give an entire sequence, step 1, end user types a command on the Sqoop client. Step 2, Sqoop connects to the relational database and gets the metadata about the table. Based on that, Sqoop generates a MapReduce code and submits it to the cluster. Step 5, resource manager fires an app master. Step 6, app master fires 4 MapReduce jobs. It fires 4 MapReduce jobs. And each MapReduce job will basically take 25% of data and get the data back to HDFS cluster. This is precisely how Sqoop works. Now, this version of Sqoop, where all the intelligence majorly was on client, was called as Sqoop 1. Now, one major limitation in Sqoop 1 was, for every new database, let's say first you have Oracle, you will need a JDBC connector on the client. Then you move to MySQL, you needed a JDBC connector. To solve that problem, what was created was Sqoop 2 server. Sqoop 2 server exactly works like Sqoop, just that it's slightly central in its approach. So now let's look at Sqoop 2 server also. So, you have a client here and there is a Sqoop server. So, on our laptop we will have Hadoop client, we will have Sqoop client, we have Hadoop, and you have Sqoop 2 server. Now, from your laptop, the first request goes to Sqoop 2 server. Sqoop 2 server will get the metadata and based on that submit the MapReduce job. 4 mappers will run and the output will go to the cluster. Now, with Sqoop 2 being central, the biggest benefit of this architecture is for every new database that we add in our stack, we don't have to have JDBC connectors on the Sqoop client. Sqoop 2 server will manage that centrally. So, this is called as Sqoop 2 server. So, in a nutshell, Sqoop is a tool that lets you ingest data from relational database to HDFS. In Sqoop 1, the client will have JDBC connector for all the databases. In Sqoop 2, the Sqoop 2 server will have all the JDBC connectors. So, this is difference between Sqoop 1 and Sqoop 2. Now, let's understand Sqoop in the form of this presentation. So, in this particular presentation, we are going to cover what is Sqoop, the Sqoop import tool, importing a table, specific columns, importing using a SQL query, export tool and exporting a table. In the next section, there is a lab on Sqoop. So, we will be doing that in the next section. So, let us first talk about overview of Sqoop. What really happens is Sqoop is a tool that gets data from relational database to HDFS. A client executes command and then Sqoop executes that command in the form of MapReduce jobs and gets you the data. This is how Sqoop works. This is precisely the way we saw the diagram in our drawing tool. Next, what exactly is Sqoop import tool? It's basically an import command. The import command will basically import data from relational databases to HDFS, and it also accepts options like the connection string, the username, password and the table. We will be looking at a couple of examples in this slide as well as the hands-on. Next, how do you basically go about importing tables? So, you start with Sqoop import, connect JDBC MySQL, your database host name and the database name, table, let us say stock prices. You can specify which directory in HDFS this data should be placed, which directory in the database this data should be placed, and this should be stored as a text file. So, you could basically specify that. This is how you import data from a relational database to HDFS. Next, what if I want to import some specific columns from a relational database? Even that is possible using Sqoop. So, we start with Sqoop import, connect JDBC MySQL, host NYSE, table, stock prices. What we want is only 4 columns: stock symbol, volume, high, closing price. The target directory that we want is data, daily highs. We want to store it as a text file and split by stock symbol, and we want number of mappers to be 10. So, by default number of mappers used are 4, but in this case we are specifying that the number of reducer mappers should be 10. We can specify that. And in case the table does not have a primary key, we can specify the Sqoop tool that let's split the rows based on a column, let's say stock symbol. So in this case, what happens is, first Sqoop would go to the relational database and check if stock prices table is there, and if columns like stock symbol, volume, high and closing price are there. If it is, the Sqoop tool will generate a map only map reduce program, in this case with 10 mappers, and all the records would be split based on stock symbol column into 10 chunks, and each mapper will take 10% of data and dump it into HDFS. So the final outcome of this command would be that there will be a folder created in HDFS called data daily highs, and there will be 10 files in which the data would be there. Each file will have 10% of data. Now let's talk about how can I run a SQL query in Sqoop so that we only get certain data that satisfies the condition. So we start with Sqoop import connect JDBC MySQL host NYSE, query select star from stock prices where volume is greater than $1 million or 1 million shares. Now we've given this condition, whoever fills or whichever row is fulfilling this condition, only that data will be imported to HDFS. Only that data will be imported to HDFS. Now Sqoop primarily is an import tool which can get data from relational database to HDFS, but at the same time Sqoop is also a tool that can export data from HDFS to RDBMS. The export command transfers data from HDFS to a database. You can have options like table and which export directory you want. Rows are appended to the table by default, and you also have an overwrite option. So this is how you run your export command. So how do you go about exporting? You say Sqoop export connect JDBC MySQL host NYSE. The target table is log data, and the directory that has data is data/log files, and whatever we have in our text file is separated by tab. We want to dump that into HDFS to relational database. So this is how Sqoop works. Primarily Sqoop is a tool that can get data from relational database to HDFS or HDFS to relational database. Now Sqoop had a very humble beginning, but as in when things progressed, Sqoop became more and more popular within the community. It got so popular that lot of database vendors, they started creating connectors to Sqoop. What that means is, say example, if you want to get data from Teradata to Hadoop, you don't have to use JDBC connector for Teradata. In fact, Teradata has created its own custom connectors. With custom connectors, you can have data which is moving from relational database to HDFS using the native protocol of the database and not JDBC. And it can give you immense amount of performance. So there are custom connectors available for Netezza, Teradata, MySQL and Oracle. So the point is, in case you are importing data from Oracle, Teradata, Netezza, these kind of databases, don't use the JDBC connector, use the custom connectors. Custom connectors are not open source, but they are free and you could easily find them on Cloudera's website. So a quick summary, we've seen what is Sqoop, how you can import data, how you can export data, how Sqoop works internally, it creates 4 mappers and so on and so forth. That was all about Sqoop. Thanks for watching this video.